Hello friends, I welcome you in lecture number 41 on double integrals. In this lecture we will discuss how to apply substitutions in double integrals. In previous lecture we have discussed about change of variables in double integrals and we had seen this result that if we consider the transformation of variables x, y to new variables u and v by these functions x equal to g of uv, y equal to h of uv, then double integral of function f with respect to xy over region R is converted into the double integral in variables u and v, and this f of xy will be converted in terms of u and v by substituting values of x and y in terms of u and v, and this dx dy will be equal to absolute value of Jacobian times du dv, where j is the Jacobian of xy with respect to uv and is given by this determinant del x by del u, del x by del v, del y by del u, del y by del v, and we know how to evaluate this determinant. So with this in mind, we try to understand that method with the help of this example. So you can see here given function is e raised to x minus y divided by x plus y. So you can see that we cannot integrate this with respect to x or with respect to y. It is merely impossible to integrate this function with respect to x and y without applying this substitution of double integrals. So from this function we can have the idea that we can change the variables x and y to new variables by taking x minus y equal to u and x plus y equal to v. If I apply this change of variables, my function will be e to the power u divided by v, and this is very easy to integrate with respect to either u or with respect to either v. So here we will apply this change of variables, and we have to find out the region of integration corresponding to new variables also, and region of integration in given variables is region bounded by x equal to 0, that is y axis, y equal to 0, that is x axis, and the line x plus y equal to 1. So first we write down that given region, the region, original region in x and y we will denote by R, is bounded by x equal to 0, y equal to 0, and the line x plus y equal to 1. So this will be a triangle and we can easily sketch it. So first I sketch the region which is given for variables x and y, and it is the region bounded by x equal to 0, y equal to 0, and this line x plus y equal to 1. So this is y axis that we denote by x equal to 0, x axis is denoted by y equal to 0, and this line x plus y equal to 1 will pass through 0 1 and 1 0. If we take x equal to 0, we will have y equal to 1, that is this point, and for y equal to 0 we will have this point. So we can sketch this line. It will pass through the point 0 1 and somewhere here, suppose this is 1 0. So we can join these 2 points 0 1 and 1 0. So this is the region bounded by x equal to 0, y equal to 0, and this line is x plus y equal to 1. This is the region of integration which is given. So this region we will denote by R, but we are not integrating over this region. we are going to apply the substitution in double integrals, and we will see what will be the image of this region under that substitution. So first we consider that substitution. We can write that let x minus y equal to u. We are changing the variables from x, y to new variables, and x plus y equal to v. Now we will require expressions for x and y in terms of u and v also, so that we can easily obtain. Suppose we add these two equations, addition of left hand side will be 2x, y will cancel out, and we will obtain 2x equal to u plus v, and this implies that x will be equal to u plus v divided by 2. Similarly, if we take subtraction of these two equations, x minus y minus x plus y, we can write one more step. We are taking subtraction of these two equations. Left hand side minus left hand side equal to right hand side minus right hand side. So here we can see x will cancel out, and here we will have minus y, that is minus 2y equal to u minus v. Therefore 2y equal to v minus u. Therefore y will be equal to v minus u divided by 2. So we obtain the expressions of x and y in terms of u and v. So this we require for Jacobian of x, y with respect to u and v. This is given by determinant with first row as partial derivatives of x with respect to u and v, and second row as partial derivatives of y with respect to u and v, del y by del u, del y by del v. Now we are having expressions of x and y in terms of u and v. So from this we can see partial derivative of x with respect to u will be 1 by 2, and same for del x by del v. Del x by del u is 1 by 2, and del x by del v is also 1/2. Del y by del u, so that we obtain from this 1 by 2 constant, derivative of v is 0, derivative of minus u is minus 1. So del y by del u is minus 1 by 2, and del y by del v will be equal to 1 by 2. So this is going to be 1 by 2 into 1 by 2, 1 by 4, minus 1 by 2 into 1 by 2, that is minus 1 by 4. So this is going to be 1 by 4 minus plus 1 by 4, that is 2 divided by 4, which is equal to 1 by 2. So therefore Jacobian of xy with respect to uv is 1 by 2. This we will require in the formula of change of variables. Now we have to decide the region of integration in uv plane. This is the region of integration in xy plane, but we are taking the transformation of xy in terms of u and v. So we have to decide the corresponding region in uv plane, so that we can decide by applying this or we can find out the boundaries corresponding to these boundaries in the region xy plane. For example, the region in uv plane corresponding to x equal to 0 can be obtained by converting this x in terms of u and v. Or suppose we have x equal to u plus v by 2. So x equal to 0, and I substitute x equal to u plus v by 2. So I will obtain that u plus v equal to 0, that is v equal to minus u. Similarly, if I consider y equal to v minus u by 2 in this boundary, y equal to v minus u by 2, so from this I will obtain v minus u equal to 0, that is v equal to u. So I obtain two lines passing through origin in UV plane. Similarly, I can find out a boundary corresponding to this line x plus y equal to 1. So x plus y is nothing but v. So this line in UV plane will be transformed into the line v equal to 1 in UV plane. X plus y equal to 1 is the line in xy plane, and using this substitution we obtain v equal to 1. So this line will be converted into v equal to 1. So in this way we have to decide the boundaries of the region in UV plane corresponding to the boundaries in the xy plane. So for that we have converted these equations in terms of x and y, that we are converting in terms of u and v. First we have converted x equal to 0 by taking x equal to u plus v by 2, and we obtain that line corresponding to this line in UV plane is v equal to minus u. Similarly, y equal to 0 is converted into v equal to u, and x plus y equal to 1 is converted into v equal to 1. So the region in UV plane will be the region bounded by v equal to 1, v equal to minus u, and v equal to u. So in this way we can decide the region in the UV plane, which is the image of the region in the xy plane under selected transformation. So let me sketch in the middle. So now we are sketching the region in the UV plane. So suppose these are the u axis and v axis. U axis means v equal to 0. Here we have v axis that we denote by u equal to 0, and suppose this distance is 1. So we have to sketch 3 lines, v equal to u, v equal to minus u, and v equal to 1, that we have obtained using the transformation in the curves in xy plane. These were the boundaries of curves in xy plane. X plus y equal to 1 is transformed into v equal to 1, x equal to 0 is transformed into v equal to minus u, y equal to 0 is transformed into v equal to u. So we obtain these 3 curves, v equal to 1, v equal to u, and v equal to minus u. So we have to sketch the region in UV plane bounded by these 3 curves or these 3 lines. Now we can see, if I take v equal to 1 here in this, then I will obtain u equal to 1. So this line is passing through 1 1. If I take v equal to 1 in this equation, I will obtain u equal to minus 1. So it is passing through minus 1 1, and this v equal to 1 is the line parallel to u axis, horizontal line. So these lines v equal to u will intersect v equal to 1 at point 1 1, v equal to minus u will intersect v equal to 1 at minus 1 comma 1. So we can roughly consider that this distance is 1. So this point is going to be 0 1. Somewhere here, suppose this distance is 1, then this point is 1 comma 1, this is 0, and here we can consider minus 1. So here I have this point minus 1 comma 1. So now we know that this v equal to u is the line passing through origin, and it is passing through this point also 1 1. So it is the line joining these 2 points. Similarly, v equal to minus u is passing through minus 1 1 and origin. So that will be the line which we will obtain after joining these 2 points. And we are interested in the region bounded by these 3 lines. So this is the line v equal to 1 parallel to u axis. This is the line v equal to minus u, and this is the line v equal to u. so that we can write here this line is v equal to 1, this is v equal to u, and this is v equal to minus u. So our region in UV plane is the region bounded by these three lines. So this is the region of integration in UV plane, and we are going to integrate in UV plane after changing the variables. So we must be clear about the region of integration in UV plane. So using this region of integration, we will decide the limits of integration for new variables u and v. Now here there are two possibilities to find out the limits of integration. Either we can select vertical line passing through the region or horizontal line. So which one will be easy? So our region looks like this. It is a triangular region. Now suppose I consider vertical line passing through the region, then you can see in this part, if we break this region into two parts, and if I consider vertical line in this part, then it will enter the region on v equal to minus u. And if we sketch the vertical line to the right side of this line, then it will enter the region on the line v equal to u. So if we select vertical line, or if we want to integrate with respect to v first, we have to divide the region of integration into two sub-regions, and then we have to find out integral over r1 and integral over r2, and then we have to take their addition. But instead of this, if we select horizontal line, or if we integrate with respect to u first, then we can see horizontal line will enter the region on the same curve. If we sketch horizontal line anywhere here, it will enter on the line v equal to minus u, and it will leave on the same line v equal to u. So it is better to consider horizontal line to integrate in the UV plane. So we will consider the horizontal line passing through the region of integration. Now as usual, we have to decide the points at which line enters the region and line is leaving the region. So here line enters the region on the curve v equal to minus u. So here we mention that enters at v equal to minus u, and it leaves on the line v equal to u. So we write that line leaves at v equal to u. That means limits of integration for variable here on horizontal line v becomes constant. So this will be the limits of u. So we have to convert u in terms of v. So u will be minus v, and here we will write in this way u equal to v. On the horizontal line, variable v becomes constant and u is changing. So it enters on the line v equal to minus u. So from this we obtain u equal to minus v, and it leaves on the line v equal to u. That means u equal to v. So limits of integration for variable u will be from minus v to v. Okay, we can write here that limits of integration for variable u are from minus v to v. Now to decide the limits of integration for v, we can find out the lowermost point of the region and uppermost point of the region. This is the lowermost point of the region. At this point value of v is 0. So lower limit for v will be 0. And all these are uppermost points of the region, and at all these points value of v is 1. So upper limit for v will be 1. So limits of integration for u are from minus v to v, and limits of integration for v are from 0 to 1. So these are the limits of integration in the UV plane, and we can denote this region by capital G. So G is the region in the UV plane. So what we have done up to this, we have first decided the region of integration in the XY plane. Then we have converted boundaries of region in the XY plane in terms of u and v by considering this transformation. We have also obtained Jacobian of xy with respect to u and v, that is 1 by 2. After that, we have sketched the region of integration in the UV plane that we will require for integration in the UV plane. So using this region of integration, we obtain the limits of new variables u and v. Now we apply the change of variables formula. So our integral in xy plane was e raised to x minus y divided by x plus y dA over r. So this we are now converting in terms of u and v. So we replace x minus y by u, x plus y by v. That was the transformation which we have selected. X minus y equal to u, x plus y equal to v. So function is converted in terms of u and v. dA, that is either dx dy or dy dx, that is going to be absolute value of Jacobian times du dv. So that we write here absolute value of Jacobian. Don't forget to write down this absolute value of Jacobian integration with respect to u and v over the region G in the UV plane. Now we have obtained the limits of integration in the UV plane. Let me write this properly. Okay, double integral over G in the UV plane. This dx dy or dA is replaced by absolute value of Jacobian times du dv. Now we have used the horizontal line, so order of integration is first with respect to u and then with respect to v. Limits of u are from minus v to v and limits of v are from 0 to 1. So first integral is with respect to u, limits of u are from minus v to v, limits of v are from 0 to 1. Function is e raised to u divided by v. Jacobian has value 1 by 2, therefore absolute value of Jacobian is also 1 by 2. So that we write absolute value of Jacobian is 1/2 du dv. So first integral is with respect to u. We can take this 1/2 outside the integral. We keep this v equal to 0 to 1 as it is, and we integrate this function with respect to u by considering v as constant. So integral of e raised to u by v is e raised to u by v divided by coefficient of u, which is 1 by v. V is considered as constant because we have integrated with respect to u. Limits of u are from minus v to v. We are integrating with respect to u, so we consider 1 by v as constant. Integration is with respect to u, so as you know, this is equal to divided by coefficient of u, which is 1 by v. Because v is constant, 1 by v is also constant, so we are dividing by coefficient of u. And here after substituting limits, we will integrate with respect to v. So we can rewrite this as v equal to 0 to 1. We can rewrite this as v times e raised to u by v, and after this step we will put u equal to minus v and v. Now we consider the limits. Upper limit for u is v. So if I take u equal to v, I will have e raised to v by v, that is e raised to 1, which is e, minus v times e raised to minus v divided by v, that is minus 1. So we obtain e raised to minus 1 integral with respect to v. So now here e and minus e are constants, so we can again rewrite this as e raised to minus 1, that we can rewrite as minus 1 by e times v. Integral is with respect to v. This e minus 1 by e is constant, that we can take outside integral, and integral of v with respect to v is v square by 2. Limits of integral for v are 0 to 1. So this is going to be, this again we can rewrite as e square minus 1 divided by e. If we take v equal to 1, we will have 1 by 2, and for v equal to 0, we obtain 0. So now we can see in the numerator we will have e square minus 1. Here we will have 1 by 2 into 1 by 2, that is 4, and this e. So value of given integral is e square minus 1 divided by 4e. So in this way, using the substitution in double integrals or using the change of variables, we can easily evaluate this type of integrals by changing the variables. So here you can see original integral in x and y variables were not easy, or it was like impossible to integrate this function in terms of x and y. So we have converted this function in terms of new variables u and v by considering x minus y equal to u and x plus y equal to v, and we are able to easily integrate this in terms of new variables u and v. All we have to take care is we have to find out the region corresponding to the region in the xy plane. We have to remember that this dx dy will be replaced by absolute value of Jacobian times du dv, and we have to convert everything which is in terms of x and y in terms of u and v, and we have to decide the limits of integration for new variables u and v. For that we have to sketch the region of integration in terms of new variables u and v, and that region of integration will be obtained by converting the boundaries of region in xy plane into the new boundaries in terms of u and v. So first we had sketched the region of integration in xy plane. After that we converted boundaries of this region from xy to the u and v variables. Okay, so this is very easy, but we have to take care of all these different types of steps. So this is all about this session. I hope you have understood how to consider the change of variables in double integrals. In upcoming lectures, we will discuss some more problems of this type. Thank you.